Beyond earthquakes and thunderstorms, there are countless other phenomena currently happening in the universe which you are not aware of. Unsurprisingly, many of these phenomena are backed by creepy facts you know little about. Well, after some careful research, we have gathered some of the creepiest facts about the universe you need to know. Are you ready to expand your knowledge of the universe? Join us as we explore 20 creepy facts you were never told about the universe. Number 20. Life on Earth originated in space. The notion that life on Earth originated in space is intriguing, and recent research has provided compelling evidence to support this theory. Cosmic dust particles abundant throughout the universe are thought to have played an important role in the evolution of life on Earth. Phosphorus is a critical component for life because it's required to form DNA and other biological molecules. It is thought that cosmic dust particles entering the Earth's atmosphere released phosphorus, which went through a series of chemical reactions before becoming available for biological use. Meteoric deposits in various locations worldwide, including the Rocky Mountains, the Himalayas, and the Andes, provide evidence for this theory. These deposits are rich in phosphorus and other elements required for life, implying that they were brought to Earth by extraterrestrial particles. Number 19. Space's Great Attractor. Have you ever heard of the Great Attractor? Well, it's a strange phenomenon that scientists are still trying to figure out, but one thing is certain: it's extremely powerful. The Great Attractor is a gravitational anomaly found in the constellation Centaurus. It got its name because it attracts galaxies at breakneck speed, pulling them in from all directions. Galaxies are drawn towards the Great Attractor at an astonishing speed of more than 600 kilometers per second. To put that in context, that is faster than the speed of the Earth's orbit around the Sun, which is approximately 30 kilometers per second. But what is the source of this incredible gravitational force? Well, scientists are still attempting to solve this mystery. Some theories propose that it results from an unseen massive cluster of galaxies, while others propose that it results from an unknown cosmic structure. Whatever the cause, the Great Attractor remains one of the universe's most fascinating and creepy phenomena. Number 18. Did you know that on Venus a day lasts longer than a year? It may appear weird, but it's true. While Venus orbits the Sun in 224 Earth days, it rotates on its axis in about 243 Earth days. But what is the source of this unusual rotation pattern? Tidal locking is a natural phenomenon that frequently occurs in our solar system. Tidal locking occurs when a planet's rotation synchronizes with its orbital period due to gravitational interactions with a nearby body, such as its moon or the Sun. It means the planet's one side always faces the same direction as the object it's orbiting. Venus isn't quite tidally locked with the Sun, but its rotation is so slow that it's nearly there. And what's more, Venus has a retrograde rotation because it rotates backward compared to most other planets. But that isn't the only odd thing about Venus. It also has a dense and unstable atmosphere, with surface pressures that are more than 90 times higher than on Earth. This dense atmosphere, mostly carbon dioxide and nitrogen, creates a strong greenhouse effect, keeping the planet's surface hot enough to melt lead. Interestingly, because Venus's rotation and orbit do not match, some scientists speculate that it may have been impacted by a large object in the past, changing its rotation speed. Number 17. Quasars live in the universe. Do you know what quasars are? These enthralling objects are among the most powerful and mysterious in the universe. Quasars, short for quasi-stellar objects, are extremely bright and thought to be powered by supermassive black holes at galaxy centers. They produce enormous amounts of energy in the form of light and other forms of radiation, making them some of the most visible objects in the universe. Despite their small size, quasars are so bright they can outshine entire galaxies. They were discovered in the 1960s and have since been studied by scientists to understand better the nature of black holes and the early universe. One of the most intriguing aspects of quasars is their incredible distance from us, making them a valuable tool for delving into the mysteries of the early universe and tracing its evolution. Number 16. Sound cannot travel through space. One of the fascinating facts about space is that sound cannot travel through it. That's right, unlike on Earth or in other environments where sound can travel through a medium such as air or water, sound waves cannot propagate in space due to the vacuum. Sound is a mechanical wave that travels through a medium such as air molecules or water particles. Sound waves cannot travel without a medium, such as in space, because there are no particles to vibrate and propagate the wave. And that means there is absolutely no sound to be heard in space. Outer space contains very few particles. While there may be particles in certain areas of space, such as near stars or planets, the particle density is still very low compared to what we experience on Earth. Despite the absence of sound in space, however, other interesting phenomena can be detected and studied using instruments and tools designed to detect various forms of radiation, such as light, radio waves, and others. And by studying these, scientists have been able to explore and learn more about the vast and mysterious universe beyond our planet. So the next time you look up at the stars and wonder what it's like up there, remember that it's not only silent, but also an entirely different environment where the rules of physics work a little differently than they do here on Earth. Number 15. Metals can bond in space for all eternity. Did you know that two metals with identical properties can naturally bond and unite for eternity in the vast expanse of space? It's an amazing sight that we don't often see here on Earth. Metal fusion on our planet is a complex process requiring extreme temperatures and pressures. However, in the void of space, things work a little differently. The cosmic machinery works so that everything similar is destined to join for all eternity. When two metals with identical properties collide in space, powerful electromagnetic forces pull them together. These forces are so powerful that metals can combine to form a single material. And because there is no air or other substance in space to interfere with the bonding process, the metals can stay together for an extremely long time, if not forever. Cold welding is the process of bonding metals in space, and it has some fascinating implications for space exploration and technology. Scientists have been investigating this phenomenon to create new methods for joining materials in space, which could be extremely useful for building structures and equipment in zero-gravity environments. Number 14. There are an infinite number of stars. The universe has more stars than sand grains on Earth's beaches combined. The universe's star count is estimated to be around 3 sextillion, which is a 3 followed by 23 zeros. To put that into perspective, counting every star in only the Milky Way galaxy at 1 per second would take you over 3,000 years. The universe is vast, not only in terms of the number of stars, but also in terms of the possibility of life. With so many stars in the universe, countless planets could likely support life as we know it, and possibly even forms of life that we don't yet understand. And despite our enormous potential, we remain insignificant in the grand scheme. The universe is so vast that we can't even fathom its true scale, and it serves as a sobering reminder of how insignificant we truly are. Number 13. A teaspoon of a neutron star is heavier than Mount Everest. Although it is difficult to comprehend, neutron stars are really dense. These incredibly small objects form when a massive star explodes in a supernova, leaving behind a core densely packed with neutrons. Neutron stars are so dense that a single teaspoon of their material would be heavier than Mount Everest. It's difficult to understand how much mass can be packed into such a small volume, but it gives us an idea of the incredible forces at work in the universe. Neutron stars are also notable for their extremely fast rotation. Given their size and density, some can rotate up to 600 times per minute. Scientists are still working to understand these objects better and the physics governing their behavior. Still, their discoveries have given us a new appreciation for the universe's incredible complexity and diversity. Number 12. We know nothing about 95% of the universe. Even with the progress we've made in science, a significant portion of the cosmos remains a mystery. As much as 95% of the universe remains beyond our understanding. Indeed, the objects we can see with our eyes and devices account for less than 5% of the universe. The remaining 95% comprises dark energy and dark matter, two mysterious substances we still don't fully comprehend. Dark energy is thought to be the force accelerating the universe's expansion. On the other hand, dark matter is known as matter that does not interact with light or other electromagnetic radiation, making detection difficult. Despite decades of research, scientists still don't know what dark energy and dark matter are or how they work. In many ways, they are some of the universe's most elusive and mysterious substances. This ignorance of 95% of the universe is a sobering reminder of how much we still have to learn. It is, however, an exciting opportunity for scientists and researchers to continue pushing the boundaries of what we know and uncovering new insights into the universe. Number 11. Heavy metals such as gold and platinum are formed by neutron star mergers. The origin of heavy metals such as gold and platinum is one of the universe's most intriguing mysteries. Scientists have long wondered how these precious metals formed, and they believe the answer lies in the merger of neutron stars. Neutron stars are extremely dense objects formed when a massive star explodes in a supernova. Then, when two neutron stars collide, an enormous amount of energy is released as gravitational waves. However, they also produce some of the universe's most massive elements. Extreme conditions such as high temperatures and pressures can result in the formation of heavy elements such as gold and platinum during a neutron star merger. Scientists believe this is how most of the gold in the universe formed. Number 10. There is a limit to the area we can see. The finite speed of light and the universe's age limit how far we can see in the universe. In a vacuum, light travels at a constant speed of about 3 million meters per second. However, the universe is not static and has expanded since the Big Bang 13.8 billion years ago. It means that light from the universe's most distant objects has traveled for billions of years before reaching us on Earth. The cosmic microwave background radiation, the afterglow of the Big Bang, is the furthest we can see. This radiation is known to have been emitted around 380,000 years after the Big Bang, when the universe became light transparent. Its faint glow can be seen from every direction in the sky and is understood to be the universe's oldest light. The cosmic microwave background radiation is thought to come from around 46.5 billion light-years away from Earth, which is considered the edge of the observable universe. However, understanding that the observable universe does not equal the entire universe is critical. The universe may be much larger than the observable universe, but due to the speed of light, we cannot see beyond it. The unobservable universe is the concept of the universe beyond the observable universe, and is thought to contain regions of space-time that are forever beyond our reach. Number 9. A black hole is a portal to another universe. Black holes have long captivated our imagination as some of the universe's most mysterious and powerful objects. When a massive star collapses in on itself, it creates a region of space with an intense gravitational field that can even trap light. However, recent theories suggest that black holes may not simply be a stop for matter and energy. Indeed, some scientists believe that black holes may be a portal to other universes, providing a glimpse into realms beyond our own. According to one theory, our universe may have originated inside a black hole, and black holes may act as a door to other universes with different physical laws and properties. This concept is based on an oscillating universe, in which the curvature of space-time and the universe's acceleration can create new universes. Number 8. Wormholes are temporary tunnels in the universe. Wormholes are an intriguing physics concept frequently depicted in science fiction as shortcuts through space and time. These speculative objects are considered space-time tunnels connecting distant regions of the universe. While wormholes are still theoretical, recent research has shed new light on their potential properties and how they might work. According to one theory, wormholes are temporary structures that form and dissipate within the fabric of space-time. Researchers demonstrated that a particle can pass through a wormhole and exit at a different point in space-time. This discovery implies that if stable wormholes exist, you can use them to travel the universe. Isn't that awesome? However, physicists continue to face significant difficulties in understanding the stability of wormholes. The energy and matter required to create and maintain a stable wormhole are beyond our current technological capabilities, and the extreme conditions inside a wormhole would make it extremely dangerous, if not fatal, to traverse. Nonetheless, research into wormholes continues to push the boundaries of our understanding of space and time, offering tantalizing prospects for future exploration and discovery. Number 7. Your DNA stretches 17 times to Pluto and back. Did you know that our DNA could stretch to Pluto and back 17 times? It's an incredible fact demonstrating how complex and amazing the human body is. But what exactly is DNA? DNA, as many of you may already know, is deoxyribonucleic acid, containing all the genetic instructions for constructing and maintaining living organisms. It's essentially the blueprint that determines everything from eye color to disease susceptibility. Now, if you were to unravel your DNA and stretch it end to end, it would be at least 37 trillion cells, with each DNA about 5 centimeters long. In context, the distance between Earth and Pluto is approximately 5.3 billion kilometers, meaning your DNA would stretch to Pluto and back 17 times. Your DNA is so long that it would outdistance the Voyager 1 spacecraft, which is currently over 23,500 million miles away from us. That is truly astounding. And yet, despite its enormous length, your DNA can still fit inside the tiny nucleus of each of your cells. How is this even possible? To fit inside the nucleus, DNA is packaged into structures called chromosomes, which are highly condensed and tightly coiled. So the next time you're down about your size or stature, remember that your DNA alone can span the vast distance to Pluto and beyond. It's just another reminder of how truly amazing and awe-inspiring the human body is. Number 6. A mysterious force called dark matter exists. Dark matter is important in the universe's structure and evolution despite its invisibility. Its gravitational effects can be seen in a galaxy's rotation and the universe's distribution of matter. Scientists believe that dark matter accounts for approximately 27% of the total mass energy of the universe, with visible matter such as stars, planets, and galaxies accounting for 5%. The remaining 68% is considered dark energy, a mysterious force that hastened the universe's expansion. Despite decades of research, the nature of dark matter remains one of astrophysics' greatest mysteries. Many theories have been proposed, ranging from particles that only interact weakly with ordinary matter to exotic forms of matter that have yet to be imagined. Number 5. We're all made of stars. Did you know that we're made up of stars? Our bodies are made entirely of stardust. The elements that make up our bodies were created billions of years ago in the nuclear furnaces of stars that lived and died. Nucleosynthesis produces heavier elements such as carbon, nitrogen, and oxygen, all required for life. When stars exploded in supernovae, these elements were ejected into space. These elements came together to form new stars, planets, and life, so in a sense, we are all made of stardust. Carbon in our DNA, calcium in our bones, and iron in our blood were all created in the cores of stars that exploded long before our solar system formed. This concept is both fascinating and humbling. It reminds us that we are a part of something much larger than ourselves and profoundly connected to the universe. Remember that you are made up of the same material as the stars and that we are all part of the same cosmic story the next time you take a look up at the night sky. Number 4. Countless parallel universes could exist. The multiverse theory is a fascinating topic in physics, and while it is still only a theory, scientists are paying more attention to it and studying it. Multiple parallel universes raise many questions about the nature of reality and our universe. Some physicists believe that parallel universes could help explain some of quantum mechanics' mysteries, such as the strange behavior of subatomic particles. According to one interpretation of the multiverse theory, every possible outcome of a quantum event occurs in a separate universe, implying that every decision and possibility exists in a separate parallel universe. According to this theory, there could be infinite parallel universes, each with its physical laws and constants. While parallel universes may appear fanciful, it is gaining traction in the scientific community. According to some physicists, the detection of gravitational waves may be evidence of the existence of parallel universes, as the waves may have originated from the collision of two universes. The study of parallel universes and the multiverse theory is still an exciting area of study that could provide valuable insights into the nature of our universe and reality itself. Number 3. Gravitational waves exist. Albert Einstein's theory of general relativity, which describes how gravity works, was the first to predict gravitational waves. According to general relativity, massive objects warp the fabric of space-time, causing ripples to spread outwards at the speed of light. Gravitational waves cause these ripples. Detecting gravitational waves is a significant scientific breakthrough because it allows us to study some of the universe's most extreme events, such as black hole mergers and supernova explosions. Scientists can learn more about the properties of black holes and neutron stars and the fundamental laws of physics by studying the gravitational waves emitted by these events. And several more gravitational wave events have been observed since the first detection in 2015, including the collision of two neutron stars. These findings established the existence of gravitational waves and spawned a new branch of astronomy known as gravitational wave astronomy. Scientists hope to use gravitational waves to study the early universe and unravel the mysteries of dark matter and energy. Number 2. The universe is expanding at a rapid pace. Observations of distant supernovae are one of the most important pieces of evidence of the universe's accelerated expansion. The light from these supernovae was dimmer than expected, indicating they were further away than previously thought. It led scientists to believe that the universe was not only expanding, but that it was speeding up over time. The current leading theory for this acceleration is dark energy, a mysterious form of energy thought to account for approximately 68% of the universe's total energy density. Dark energy is thought to have negative pressure, causing it to work against gravity and push galaxies apart. However, the nature of dark energy is still largely unknown, and scientists are still trying to figure out what it is. The discovery of the universe's accelerated expansion has profound implications for our understanding of the universe. It implies that the universe may expand indefinitely, with galaxies increasingly separating. It also raises questions about the universe's ultimate fate in the future of our galaxy and planet. Number 1. The end of the universe could be a Big Rip. The Big Rip is a hypothetical event that will bring the universe to an end. It's a theory that suggests that at some point in the future, the universe's expansion will accelerate to the point where it will tear apart all matter, including atoms. It would occur because the gravitational forces that hold matter together would be overwhelmed by the force of dark energy. This mysterious force causes the universe to expand at an accelerating rate. The Big Rip theory, first proposed in 2003, is still being researched and debated by scientists. One of the most difficult aspects of studying the Big Rip is that we don't fully comprehend the nature of dark energy. It's unclear whether dark energy's power will grow stronger over time or if it will eventually fade. The Big Rip would begin at the cosmic horizon, where the universe's expansion has caused distant galaxies to recede beyond the reach of our telescopes. As the universe expands, the cosmic horizon gets closer and closer until it reaches our galaxy. At that point, the force of dark energy would tear apart the Milky Way, our solar system, and finally our body's atoms. While the Big Rip is a stark reminder of the universe's impermanence, it's important to remember that it's only one of several possible end-of-the-world scenarios. Other possibilities include the Big Crunch, in which the universe eventually collapses, and the heat death, in which the universe expands until all matter is evenly distributed and no more energy can be expended. Which amongst these facts surprised you the most?